Hello class, in this lesson we're going to learn about special right triangles. First, I'd like to talk a little bit more about the converse of the Pythagorean theorem. We proved this in our previous lesson, but we didn't really apply it. So let's look at how we can apply this theorem. If we're given three side lengths of a triangle, we can plug them into the a squared plus b squared equals c squared equation and see if it checks. If it checks, then it's a right triangle. If it doesn't, then it's not a right triangle. And the one thing you have to be careful of is always take your biggest measurement and substitute that for the hypotenuse. So in this case, we want to see, is 8 squared plus 15 squared equal to 17 squared? If we simplify each side of the equation, we end up with 289. So yes, this triangle is a right triangle. Same idea over here. Is 5 squared plus 8 squared equal to 9 squared? On the left-hand side, we end up with 89, and that's not equal to 81. So this is not a right triangle. So let's look at our first type of special triangle. Here we start with an equilateral, and we drop an altitude to this base down here. Are these triangles congruent? Why or why not? Yeah, they each have these right angles, so they both have that 90. They both have these angles that measure 60, and they both have these sides of 2. So by angle, angle, side, they are congruent. So what's the shorter leg, and what are the third angles? Well, if we look at this triangle here, we know that the whole base here is 2. And since these are congruent triangles, these two legs have to be the same length. So if that's 2 and split in half, they have to both be 1. And the third angles, well, if that's 90 and that's 60, that would have to be 30. So you can get a sum of 180. You could also say that you know this whole angle is 60, and these two angles are congruent, so half of 60 is 30, same answer. How do we figure out the length of the altitude? So I don't know, how long is this segment? Usually with altitude, we use the word height, where you can use h to represent its length. And you just plug into the Pythagorean theorem, plug into that equation. So we end up with h squared equals 3. So our answer is the square root of 3. We'll go back and label our diagram. There we go. So let's write our three ratios here. Shorter leg to hypotenuse would be 1 to 2. Longer leg to hypotenuse would be square root of 3 to 2. And finally, shorter leg to longer leg would be 1 to the square root of 3. And now we can use our within figure ratios to solve this problem. We know by angle, angle, any 30, 60, 90 triangle is going to have these same ratios when we compare their corresponding pieces. So if we know the hypotenuse is 16, what are the legs? So the hypotenuse has length of 16, and we're looking for the legs. So we know that the shorter leg to the hypotenuse is 1 to 2. So that's got to be the same as a over 16. Apply the cross product, and you get 8. Same idea for the longer leg. We know that the ratio of the longer leg to the hypotenuse is radical 3 over 2. So it has to be the same as b over 16. Apply the cross product, and we get 8 radical 3. So there are our two answers. So this is called a 30, 60, 90 triangle. And you have to have this relationship memorized. Whenever you have a triangle with these angle measurements, the shorter leg is going to be it's going to be x in this diagram, and it's going to be what we can base all the other measurements off of. So to find the longer leg, you just multiply that shorter leg by the square root of 3. To find the hypotenuse, you just multiply that shorter leg by 2. That's always going to be the case. So if you want to look at solving this with an alternate method, we can just apply these two equations that we just learned. And it's really mathematically equivalent to what we did already with ratios. So either way is fine. So we already know that the hypotenuse is 16, and that's going to be twice the length of the shorter leg. So it's going to be twice a divided by 2, and we get 8. And now that we know the shorter leg, to find the longer leg, you just multiply that by the square root of 3. So that would just be 8 radical 3. Same answers, slightly different method. Here is our second type of special triangle. Here we have an isosceles right triangle. And what are the missing angle measurements? Well, we know that they have to be congruent by the base angles theorem. And we know that all three of them add up to 180, and this is 90 already. So these two are congruent and add up to 90, so they must each be 45. Oops, a little spoiler. So how do we figure out the length of the hypotenuse? Well, the hypotenuse squared would just be 1 squared plus 1 squared. So it would just be, c squared would be 2, so the hypotenuse is the square root of 2. So that's our special relationship here. So when we're writing the ratios in this case, do we really have to write all three of those? Well, not really. The shorter leg to the hypotenuse is going to be the same as the longer leg to the hypotenuse. And the shorter leg to longer leg is just 1 to 1. That's not very interesting. So you only really need one ratio here. So the only ratio we care about is leg to hypotenuse. And that would be 1 to the square root of 2. And so now, if we have a hypotenuse with length 20 and a 45, 45, 90 triangle, what are the lengths of the legs? So we know the ratio of one of the legs to hypotenuse, 20, has to be the same as 1 to the square root of 2. Those are the within figure ratios. Now we can apply the cross product, divide by the square root of 2. And now we want to rationalize that denominator. So we got to multiply the numerator and denominator by the square root of 2. So we end up, right? Square root of 2 times square root of 2 is just 2, right? Square root of 4. And divide 20 by 2, and we get 10 square root of 2. So this is the other important triangle you have to have memorized. Whenever you have a 45, 45, 90 triangle, to figure out the hypotenuse, it's just the square root of 2 times the length of a leg. And so if we want to solve the same problem using this equation, we can just set it up like this. The hypotenuse is the leg times square root of 2. So 20 is a times the square root of 2, divided by square root of 2. And we already saw how to rationalize that in the previous part. So it's 10 square root of 2. Very similar to what we did before, but slightly different method. In this lesson, we learned how to apply special right triangles. Thank you for watching this video.